Hello everyone, today we are starting Unit 7. Lesson 7.1 is called Graphing Exponential Functions. The general theme behind the whole unit, it's kind of a two-part theme. One is exponential functions, another one is what we call logarithmic functions, but that's nothing to worry about today. Today we're just focusing on exponential functions and we are going to be graphing. So this is a graphing day. Ultimately, we'll be using Desmos, and then we're going to talk about some other characteristics of the graph, specifically domain, range, and then something called a horizontal asymptote. So I'm going to get into that a little bit up here before I start doing my examples. I want to start with a comparison. So something we've already done, y equals x squared, also known as a quadratic. So I've got some graph paper here. It does not really have the xy axis, so I'm going to do that. And just we're going to get real basic here. So I've got a table we're going to build. So build a table like it's carpentry or something. No, a table we're going to make, table of values. So using y equals x squared. So if we plug -2 in for x into y equals x squared, to get y we need to do -2 squared, and that works out to be 4. So the point -2, 4 is a point on the graph. Similarly, if we want to do -1, that's going to be -1 squared. -1 times -1 is +1. So that would be this point here. If you plug in 0, 0 squared is 0. So that's the origin. When you plug in +1 squared is 1. That's this point here. And when you plug in 2, 2 squared is 4. That's a point here. Now I chose to plug in -2, -1, 0, 1, and 2. Of course, I could have plugged in more numbers if I had more graph paper, to work with. But I could also plug in decimals like 1.5, which would give me a point somewhere around here, or -1.5. But we're not going to waste time with that. We're just going to connect the dots, get the graph, and then we get this shape that we've spent a lot of time graphing in the past called a parabola. So hopefully you remember that. Now I want to graph a function that looks very similar, right? This was x to the second power. This is 2 to the x power. So very similar, but obviously very different as well. And we just want to look at the graphs and see what happens. So let me write that down here. So we're doing y equals 2 to the x power. If I want to plug in a -2, that's going to be 2 to the -2 power. Well, okay, -2 to the second power, that's -2 times -2. What's 2 to the -2 power? Well, if you remember negative exponents, it reciprocates, and that gives 1 over 2 to the second power. 1 over the 2 to the second power becomes 1/4. So, I got to draw in my xy axis, set of axes, whatever is the right way to say it. Good enough? Okay, go back to red. So what I've got is the point -2, +1/4. That's going to be right about there. Let's plug in a -1. That's 2 to the -1 power, which becomes 1 over 2. Remember, negative powers reciprocate. So -1 1/2 is back 1 up 1/2. That's right here. If I plug in 0, I get 2 to the 0 power. And hopefully recall anything to the 0 power is always 1. So 0, 1 is right there. If I plug in a 1, that's 2 to the first power. 2 to the first power is just 2, so over 1 up 2. If I plug in 2, 2 to the second power is 4, so over 2 up 4. Now if I connect the dots and assume it's kind of curved, I get this graph right here. If I were to plug in higher numbers like 3, that would be 2 to the third power, which is 8, so I'd go over 3 up 8, that'd be way up here somewhere. Oops, did not mean to do that. I tapped the wrong thing. Be way up here somewhere, and you can see that this graph goes on to infinity, just like you would think it would, just like these go to infinity on the parabola. But an interesting question is, what happens to the left-hand side? If we were to plug in -3, -4, -100, -infinity, which you can't really plug in infinity, but the question is, what happens to the graph there? Well, it would be nice if I didn't do that, but I could take this table that we were making and kind of augment it, give me more space to type in more numbers. Type in, I'm not typing, I'm plugging them in. So this would be 2 to the -3, 2 to the -4. And to work this out, I've kind of run myself out of room here. I'm just squeezing stuff in. 2 to the negative third works out to be 1/8, and 2 to the negative fourth works out to be 1/16. Now what's 1/8? 1/8 is half as big as the previous point right there, or half as high. 1/16 is half as high as that. What happens is this side of the graph starts getting really, really close to the x-axis. It kind of hugs the x-axis. But it never dips down beneath the x-axis. It kind of levels off in a way. I'm going to say parallel, even though that's the wrong word, but it appears that these two become parallel. Now, parallel means that they're both straight lines. And obviously, the x-axis is a straight line. This is technically not a straight line because this point was lower than that point. And the next point, if I had room, would be lower than this point. So it gets lower and lower, or closer and closer to the x-axis every step of the way, but it never touches it. Some people use a phrase that's technically not right, but they'll say it gets infinitely close to that line. In other words, you can go to infinity, or in this case, negative infinity, and it'll get extremely close without ever touching it. There's always going to be at least a point in between. So there's always some sort of a space in between. So that's the characteristic of this exponential graph. Now, are we going to do our homework plotting points? No, that's not really the point. Haha, nice pun. All right, I am going to do number 1 and 2, so you don't have to do number 1, even though it's an odd problem. I kind of want to show you the difference between what happens when you have a whole number versus a fraction as a base. By the way, exponential functions, an exponent has 2 parts. It has a base and a power, so keep that in mind. So a whole number base, the variable is a power. Whole number base, the variable is a power. The key thing here is that the variable is the power, not the base. So if I'm not going to plot points, what am I going to do? Well, how we do most of our graphing, which is Desmos. So let's talk about how to do this. So I am going to do number 1. You don't have to do it if you don't want to. Y equals 4, use the power button, and then put x there. And you see that graph, right? It runs, sort of along the x-axis. There's a word for that, by the way. It's called an asymptote. I'll talk about that in a minute. So it's going to kind of run along the x-axis, and then it's going to start curving upward. Now, the y-intercept is always a good place to put a point to kind of direct you. And if you can ever find any other points, like 1, 4, yeah, well, okay, my fingers aren't doing a good job, but 1, 4. If you find a couple other key points to kind of anchor your drawing, but at some point you're just going to draw an arrow, and it might not be perfect. That's good. So that is sometimes referred to as a growth function because the value grows as you go left to right. Compare that now to 1/3 to the x. So let me get rid of that and type in y equals. Now I'm going to do parenthesis fraction, 1 on top, 3 on bottom, and then outside of the parenthesis, hit the power button, and that's where your x goes. And here you see it's basically the same graph, but it goes the other way around. We still have an asymptote here. It still kind of hugs the x-axis, but it does in the positive direction, and it kind of curves up over here. Now, is that a good job? Probably not. Are there any key points that would have made more sense? -1, 3, is that -1, 3? So that would have been better. Here, let me just redo that part. I'll make the curve a little more true to form. It goes kind of like this. Now this does not go straight up and down. It still heads to the left to negative infinity. So it goes left and up forever, but it's just very, very steep. But anyway, there's the graph. Well, to the best of my ability. I could have made this hug the line a little closer, I guess. But this is important. You never want this side to cross the line. All right, let's go back. So that line that it doesn't cross is called an asymptote. And in general, in math and graphing, you can have 2 types of asymptotes. Well, 3 types. You can have vertical, horizontal, or slanted. All that we're going to worry about, the only thing that applies to exponential functions is horizontal asymptote. So we're only going to worry about what's called the horizontal asymptote. It's a line It's not actually part of the graph. I'm going to sneeze in a second. Sorry about that. Oh my goodness. Okay, so it's not actually part of the graph. It's more like a boundary. And in the first couple of examples, the x-axis is that asymptote. I will often change colors, maybe something that's not quite as a standout like color like yellow, and often sketch in the horizontal asymptote for my own benefit, usually to sort of show where the asymptote is. I've had classes, math classes, where the instructors have requested that you draw the asymptote. So as we go through the homework, the actual homework problems, you're going to be asked for the domain, which we'll talk about, the range, and then the asymptote for each problem. Now let's review a little bit as far as domain and range. I didn't give myself a lot of room to squeeze this in, but we've covered this already. Domain is just the x values of the graph, so x's, and range is the y values of the graph, or y's. And why is there an extra mark right there? That makes no sense. Okay, so domain is x's, range is y's. I'll talk about those now that we're doing these real examples. So you could make a table of values for every problem, pick x values, -2, -1, 0, 1, 2, plug them in for x, get your answers, plot the points, and then connect them and get your graph. That's a thing you can do, and back in the old days, that's what everyone did, old people like me who did math. But now we are going to simplify things. We'll use Desmos, and then we're going to focus on domain, range, horizontal asymptote, as well as having a fairly decent graph. You know, try to do your best to make it look good. So this is y equals 3 times, oh, I just forgot something. I mentioned how this type of graph is called a growth because it gets higher and higher. It goes upward as you go left to right. This one is actually called a decay because it goes downward from left to right. So that's not anything you're going to be tested on. I just thought I'd throw that out there. Growth, decay. All right, back to this one. So y equals 3 times the fraction 1/2 raised to the power x plus 2. Now this is tricky. Watch what happens when I type in x plus 2. X plus 2. You see how Desmos put the plus 2 in the wrong spot? The plus 2 is supposed to be up here with the x, and it's not. So what you need to do is you need to actually go parenthesis x plus 2. Then outside the parenthesis, you put plus 1. So when you type this into Desmos, you're going to want to put parentheses there. In fact, you could run through every problem and put a little set of parentheses there just to remind yourself that's how it works. Why are these all plus 2? All right, that's creepy. Okay, there's one that's not plus 2, but gee, are yours all plus 2? Plus 1, minus 2, plus 2, minus 1, plus 2, minus 2. Okay, so there's some variety in your homework. Looks like a bunch of mine are all plus 2. All right, whatever. I'm babbling. So here's my graph. You see it in green. The y-intercept is 0, 1.75. I'll go ahead and do this in red. So right about here. Can you tell what the horizontal asymptote is? How does this graph sort of level off? So look at the y values. Here's 1.049, 1.3 something, 1.2, 1.1, 1.07, 1.02, 1. Okay, Desmos. Oops, we have an announcement. Sorry about that. I'm recording this at school instead of at my house, so there can be interruptions. So anyway, the y value, Desmos at some point rounds off, and you see that the asymptote here is y equals 1. Now, if I zoom in enough, you're going to see that it actually doesn't touch 1. You see there's actually a space in between. And now I've got Desmos so it's not rounding off. But if I keep going in this direction enough, now this will take probably an hour of me scrolling, but eventually that y value will again round off to 1, and then I'd have to zoom in again to see that there's a space. So it's a resolution thing. What really happens in math is that this graph is going to kind of never touch 1, but it'll run asymptotically. Oops, I didn't want that to become a straight line. Asymptotically. I don't even know if that's a right word, but I'm going to say it. hit the home button. What happens to the rest of the graph? Well, I don't know. Are there any other key points that make it easy to graph? -2, what is that? -2, 4. And I don't think there's any other key points. So I'm going to go through there and just kind of draw my arrow like that. So there it is. There's my graph, and my asymptote is y equals 1. All right, let's talk domain and range. Domain is the x values. What x values? Like if I labeled every single point on this graph everywhere, there'd be infinitely many of them. What x values would I write in? Would I write in, 1, 2, 4, 3, 7, 1.6, -2, -5? What, or another way of looking at it is, what numbers can I plug in for x? The truth is, I can plug in any number I want. I can plug in every possible number in for x and get answers out. So the domain of this function is all real numbers. Another way to look at it is like this. The graph, how far to the left and how far to the right does it go? Now this is tricky because some people will look at this and say, well, it doesn't go to the left, it just goes up. It does go up, but it also goes to the left. It's just a really steep line. This line does keep going to the left to what we call -infinity. Clearly, to the right down here, this arrowhead, this goes to positive infinity. So the x values, -infinity all the way up to positive infinity, is just a way of saying all real numbers. So the domain of this function is all real numbers. In fact, all functions are either these growth functions or these decay functions. The domain of every exponential function is always going to be all real numbers. The horizontal asymptote is going to change. It just depends on the problem and where does it level off. But the domain is always all real numbers. So that means on this homework assignment, you can go to every domain and write in the all real numbers symbol on every single one because it never changes. If it's that easy, why did we include it? Well, it's important to understand what domain means. Also, the range does change. Range is different in any particular problem, and you generally don't do one without the other. So if you're going to ask students about the range, you're going to ask them about the domain. They just go hand in hand. X's and Y's, they go together. But when you do your homework, the domain on every single problem, all real numbers. So that's easy. Let's talk about the range. So the range is, well, if the domain is the x's or the numbers you plug in, the range is the y's or the numbers you get out of the function. And that's harder to tell. Like, you can plug every number you want into the function. It doesn't matter, just plug it in and get an answer. But you can't predict what answers are you going to get out. You kind of have to look at the function to know that. The way I think of the range is this. How far down does it go? And how far up does it go? Or what's the lowest point and what's the highest point? That's how I think of range. The lowest point on this graph is 1 because 1 is an asymptote. You know what I'm going to do? I'm going to draw it in yellow like I did in those other problems. This line, in fact, 1 isn't the lowest point. It technically never touches 1. So 1 is like the boundary line that this graph never goes below. But it does go up forever. So the lowest point is 1, not including 1, and the highest point is infinity. It goes forever. The way we say that is y is greater than 1. Right? Y is greater than 1 means you don't actually equal 1, but you can get really, really close to it. 1.1, 1.01, 1.000000001 is still greater than 1, right? That means that this line gets that close to the asymptote without actually touching it. It is no coincidence that this number and this number are the same because the asymptote is a boundary line. The range is cut off by that boundary. How high or how low can it go? The boundary line helps determine that. All right, let's do a couple more. If that didn't make sense, we'll do a few more. Hopefully it'll click and I'll not do as much explaining. Let's type this next one in. So y equals 4 times 2 raised to the parenthesis x plus 2 parenthesis minus 1. So there's the graph I need to draw. Looks like I have an x-intercept at negative 4, 0, and the y-intercept is all the way up at 15, so that'd be right about there. And can you tell what the asymptote is? Does it appear to level off at negative 1? Let me trace the graph. Look at that y value, negative 0.99. Let me go further out, negative 1. Now, I know Desmos says it actually equals negative 1, but again, if you zoom in enough, there will be a gap. Holy cow, it doesn't really look like it. How far? There, I just had to zoom in a little more. So there is a gap there. It still rounds off to negative 1, but you can physically see that there is a space. So it looks like the asymptote is going to be y equals negative 1. So that's if I'm going to use my yellow here, that's why I would draw the asymptote. You don't have to, but I like to do it. It kind of shows me visually where this curve is going to kind of go. It kind of levels off there. And then here I need to curve. Oh, that's not a curve. I'm going to, I got to go through that point right. Okay, that's awful. All right, I give you permission to have a little bit of awful in your graph because clearly I can't do it right. All right, the domain is all real numbers, so it goes to the left forever, it goes to the right forever. Like I said, the domain on everything is all real numbers. The range, low to high. What's the lowest point it'll go? It appears negative 1. That asymptote is the lowest point that it goes. How high does it go? It goes to infinity. So to write that, we would say y. Remember, y is your vertical variable, up and down. Range is always going to be a y. Y is greater than negative 1. These are almost identical. One is equals, one is greater than. Does that mean range is always going to have a greater than? Not necessarily. But we'll get to one that doesn't. I hope. Yep, okay. All right, let's do this next one. So y equals negative 4 times 2, no, that's times 2 raised to the x plus 2 minus 1. And then I got to hit the home button. There we go. All right, look at this graph. That's different. It points downward. Well, can we tell what that horizontal asymptote is? I think it's going to be negative 1. Let me trace my finger around there and look at the y value, negative 1. Are there any key points I can graph? How about an intercept? Negative 17. So I definitely have an intercept here. Not going to have an x-intercept because it's never going to cross the x-axis. In fact, it's never going to go above negative 1. Right? You can see that grid mark. And if you scroll left, it just levels off. So I'll get out my yellow again. Negative 1. That appears to be my invisible boundary line. Let's see, I kind of misplaced that, right about there. Switch to red and draw my graph. So I don't have much to work with here. No key points. Oh wait, that looks to be a key point. What is that, negative 2, negative 1? Negative 4, negative 2, right there. So that gives me another focal point when I draw my curve. So it's going to curve through there, and then it's going to start hugging that line, that asymptote. So the asymptote is y equals negative 1. What is the range? Well, it's going to be y, and this is going to be negative 1, but is it y is greater than negative 1, like that problem? No, greater than would be above. This is below the asymptote, right? This whole graph is below the asymptote. So this range will be a less than, because it's below the negative 1 asymptote. So there we go. That's what we're looking for. Graph it on Desmos. Trace, or you can't trace, but draw the graph over here on the graph paper to the best of your ability. Domain is always all real numbers. Horizontal asymptote, you can tell that's where it levels off. And then the range is always y, and then it's going to be either greater than or less than the asymptote. What else is there to know? Well, there's a little bit more to know. For example, see this number and that number? see this number and that number, see this number and that number. Wonder if there's something to that. Just a coincidence? I don't know. Number 10, if that holds true, then 1 should be my asymptote. Y equals 1 should be the asymptote. Let's type it in and see. Y equals 1/3 times 7 raised to the x plus 2. Oops, that's times. Where's x? X plus 2 plus 1. Do I have an asymptote at positive 1? It kind of looks like it, right? See the y value, 1.02, and if I go over, 1.001, and if I go further, it rounds off to 1. There's my asymptote. Can I draw this graph on my paper? Well, let's see. Is there an intercept? 0, 17.3333, so somewhere around here. Are there any other key points that if I graph them would really help? I don't think there is. What is that? -1. Sorry, -2. Having an awful time here. -1. 3.333. Right around there. Let me get my yellow color out to draw my asymptote at positive 1. If you don't like yellow, you don't have to do it. Like I said, you don't even have to draw that if you don't want to. I just think it helps visually. Wow, that's awful. Okay, it's not supposed to be a straight line. It's supposed to be a curved line. But my drawing is awful. Okay, we're going to call that good enough. So domain is always all real numbers. The asymptote is y equals 1. This is above the asymptote, so the range is going to be y is greater than 1. So when you get used to this, the range is actually pretty easy. If you can figure out the asymptote, you can figure out the range. Number 12. So this is y equals -3 times 2 raised to the parenthesis x plus 2 minus 1. All right. This is a -1 here. Does there appear to be an asymptote at -1? I believe there does. Look at that y value, -1.009, and it's going to keep getting closer till it finally rounds off. So yes, indeed, there is an asymptote at -1. Though I didn't draw it at -1, I can move it up. There we go. Switch back to red. If I want to get a decent drawing, is there a y-intercept? Looks like 0, -13 is a decent y-intercept. Are there any other key points that would help? That looks kind of key right there. -1, -7. And anything else that looks like a whole number? -2, -4. Yep, -2, -4. That's probably enough. So we're kind of coming like this to there, to there. And eventually we curve and start going like that. So asymptote, y equals -1. Range, y is what? Less than -1 or greater than -1? If you said less than -1, you are doing great. And look, we're almost done. One more problem. Y equals 4 times parenthesis 1/2. Outside of the parenthesis, we want to raise it to the power, parenthesis x minus 1. Oop, not minus 1, but x minus 1. And down here, -1. Hit the home button, and this is our graph. The horizontal asymptote. I guess I haven't officially said it, but that looks like a good place to start. This appears to be -1, right? -0.999 is close to -1, and then there it is. It rounds off to -1. Oop, that's not -1, that's down here. And of course, there's the -1 right there. That's our vertical shift. Remember when we did transformations? Okay, so -1 is our asymptote. We've got an x-intercept at 3, 0. We have a y-intercept at 0, 7. Any other key points might help, but I don't even think I need any key points here. I think I've got enough. I know that this is running asymptotically, then it curves up through this point, and then it kind of keeps going to infinity. Horizontal asymptote, y equals -1. Range, y is greater than -1 because the graph is above, above the asymptote. And there it is. Now, I have not been checking myself, but I did handwrite in the answer key, so yeah, should be good. I'm going to go ahead and stop here and leave the rest of the work to you. So you don't have to do number 1, just do the rest of the odds. 3, 5, 7, 9, 11, 13. Domain, range, asymptote, get a decent graph, use some key points if you can. If you have any trouble, contact me. Otherwise, good luck, and I will talk to you another time.